A lot of you are interested in working with data, but do you know the history behind data storage? Do you know how the opportunities in this space came to be? Data is one thing that has definitely changed my life. If you don't already know, I'm a computer scientist who has primarily worked in the data space for the majority of her career. Everything I have now is because of my data skills, the job opportunities I have gotten. A lot of things have come from data, and data is definitely something that I'm heavily passionate about and I have followed very religiously throughout my career. Today's episode, we're going to dive into the history behind data storage, the story behind data storage. If you're someone who's actively engaging in this space, I think it is very important to know where the opportunities are. So let's dive into it. The first one is relational databases from 1970 to 2000. And the story behind relational databases is very interesting. I'm going to look at my phone. So if you guys see me look at my phone, it's because I'm trying to pull out notes. I have notes here. The story starts in 1970 when a British mathematician working at IBM's research lab in San Jose called Edgar F. Cord released a paper. The name of the paper is A Relational Model of Data for Large Shared Data Banks. And honestly, that was the beginning of everything. Now you have to understand, before he released this paper, data was stored in what we call a hierarchical model. And this was led by IBM. And this researcher works at IBM. However, after this research came out, IBM did not ship it because they just thought that the model they had worked. There was no need for them to ship this idea, so they kept working as they were. And then Oracle stumbled upon this research and shipped it and built the product, and it exploded. If you don't know what relational databases are, they are basically data that is stored in rows and columns. So think Excel, think SQL. SQL databases are basically relational databases. And if you work with data, this is the first thing that you learn. So now you know the history of how relational databases came about. It was a guy called Edgar F. Cord who did a research in 1970 that changed everything. This innovation was so impactful that Forbes listed it as one of the most impactful innovations in the last 85 years. And it made companies like IBM, Microsoft, Oracle, it made them a lot of money. As you can see, we still use relational databases today. So that's phase one, 1980 to the 2000s, which is the relational database era. The next era is the non-structured database era from 2009 to about 2010. And this happened due to the birth of the internet and social media and the fact that data was no longer structured. Now, the relational database era, we store data in rows and columns. But with social media, data comes in different shapes and forms. Think audio files, video files. Data is no longer structured, which means we cannot use relational databases to store this data. So what happened? The innovation happened where they had to come up with different techniques, which I'm not going to dive into in this video. This is a story time, to store the unstructured data. And that's where databases like MongoDB, Cassandra, DynamoDB, Google's Big Table, and NoSQL databases came about. This is the second tier for data storage, which happened at about 2009 to 2010. We are now in the 2020s and AI has come to life. And if you haven't used AI or LLM at this point, you are sleeping under a rock. But with LLMs, we can now use relational databases or NoSQL databases. And that is where vector databases came to life. The idea behind vector databases is that search is different. With structured databases, you query based on structured. With NoSQL databases, you query based on structure, but the way that the data is stored is different. Now, with vector databases, concepts like similarity search, semantic search came to life, which means searching based on similarity and not necessary structure. So they needed a new way to store information because storing it structurally was not working anymore. Because think about it, LLMs cannot query a structured database. LLMs cannot query a NoSQL database. So this whole new invention alongside artificial intelligence came about in the 2020s called vector databases, where we will store and retrieve information based on similarity searches. I think it's very interesting to watch the evolution of databases going from structured to no structured, and now we're in vector databases. But it doesn't end there. The story continues in 2026 with what we are now calling agent ready databases. Can you see how innovation and technology just keeps making progress? If you don't know what an agent is, you probably are living under a rock, but I'm going to bring you up to speed. Agents are pretty much AIs that can do things. So now we are no longer in the era where we're searching with just large language models. We're now using things like model context protocols, MCPs, and the goal is to create databases that agents can actually access, not LLMs this time around. Agents, right? So that's where technology is going. I think it's extremely interesting to see the progression of technology going from structured to non-structured to vector, and now we are moving towards agent-based storage in 2026 and beyond. I'm very excited to see how technology continues to progress. Again, I'm a computer scientist who loves and continues to engage in this space, and I'll continue to talk about this on this channel. If you are someone who's interested in a career in data, I think having this knowledge helps you communicate better in your interviews. So I genuinely think that this is something that you should have an interest in, and just read and research and understand why the company is making a decision to use this database. Why are they using this? Ask more questions, grow your curiosity about technology and everything in general, and it would definitely help you to become a better technologist. If you like this video, make sure you give me a subscribe, and I'll see you guys next week. Good luck.